Today's topic is representing two variable data. Our objective for this lesson is that students will be able to use Desmos graphing calculator to create a scatter plot, fit a line to a scatter plot, write the equation of the line of best fit, and compute what is known as R, the correlation coefficient. There are two essential questions that all students must be able to answer by the end of this class period. 1. Why is technology valuable when making statistical models? And 2. How do we use technology to write the equation of the line of best fit for a scatter plot? In this lesson, you are going to learn various key terms, including association, bivariate data, independent variable, dependent variable, correlation, positive and negative correlation, correlation coefficient, scatter plot, and line of best fit, which is also called a trend line or a regression line. I will urge you to pause this video to have time to read through the standards that are going to be covered today. Below is a table showing the amount of time each student studied along with your score on the test in Mr. Williams' class. Remember that our objective is to create a scatter plot using Desmos graphing calculator. The first row shows the various times students studied, and the second row shows their scores on the exam. Now, this is an example of what is termed a bivariate data. Bi stands for two, so the bivariate data simply means a two-variable data. And what are the two variables? In this example, they are the time studying and the exam score. What are dependent and independent variables? The independent variable is usually the variable that can be controlled, and in this case, it is the time spent studying. The dependent variable is the score on the exam, or the variable that is going to be affected. We know that the time spent studying affects the score on an exam. Now that we know the meaning of independent and dependent variables, let us carry out a short activity. Determine the independent and dependent variables in the following scenarios. Sarah has 4 CDs of different types of music: rock, classical, reggae, and jazz. She used a stopwatch with an alarm to make sure that she only listened to each CD for 5 minutes. Each time the alarm went off, Sarah recorded how many problems she was able to finish. At the end of the experiment, she found that she was able to concentrate the most with the jazz music, then the classical music, then the rock music, and she noticed that she did not concentrate much at all with the reggae because she felt like dancing and singing along instead of working. So the question is, what was the independent variable? Of course, type of music was the independent variable. And what was the dependent variable? The number of problems finished was the dependent variable. Do we know why? Because the number of problems finished depended on the type of music that Sarah listened to. Different rose bushes are grown in a greenhouse for 2 months. The number of flowers on each bush is counted at the end of an experiment. What is the independent variable? Of course, it is the type of rose bush. What is the dependent variable? Is the number of flowers. Example 3. 3 wax palm trees are kept at different humidity levels inside of a greenhouse for 12 weeks. and the height of the tree is measured once a week. What is the independent variable? It is the level of humidity. And what is the dependent variable? It is the tree height. The data shows time spent studying by a group of students and their corresponding scores on an exam. When constructing a scatter plot, we put the independent variable on the x-axis and the dependent variable on the y-axis. So in this very case, in constructing the scatter plot, remember to put the time spent studying, which is the independent variable, on the x-axis, and the score on the exam, the dependent variable, on the y-axis. Using the steps that are outlined in the previous lesson, use Desmos graphing calculator to create a scatter plot of the data above. To access the online graphing tool, just click on the link provided or type in www.desmos.com/calculator. This is the plot we get once we type in the x and y values in the x and y values column. We see that the dots are clustered together. We want them spread out a little bit more. To obtain this, we click on this range. Sometimes it becomes necessary to adjust the x and the y values either because they are so small or they may be so big. Now, let's take a look at these values here. We see that the smallest x number is 0 and the biggest x number in this example here is 8. So we can adjust the x values to range from 0 to 10, and this is where the change or the adjustment of the x values takes place. You can see I've adjusted the values to range from 0 to 10. And of course, we do the same thing also for the y values. The smallest y value in this example here is 67, and the biggest y value is 99. So we can choose a range of, say, from 0 to 100 and make that adjustment right here in this part. All right, so the numbers for the y values have been adjusted so that they range from 0 to 100. Next, we need to label the x and the y-axis. We know that our studied is the independent variable, so therefore it will go to the x-axis right here in this part. And the test score, which is the dependent variable, will be written right here in this space beside the y-axis. This line, which passes through these points so that we have an almost equal number of points below it as we have above it, is called the line of best fit. It takes on various names. Sometimes it's referred to as the trend line or the least squares regression line. The slope-intercept form of this line is given by y equals mx plus b, where y is the output, m is the slope or the rate of change, x is the input, and b is the y-intercept. But in this particular context, the output we know is the test score. So y equals the test score, x, which is the input, is the hours of study. M would therefore be the difference in test score per 1 additional hour of study. And B, the y-intercept, will be the score of a student who has done 0 hours of study. In order to write this equation completely, we need to have values for M, the slope or the rate of change, and B, the y-intercept. Fortunately for us, we do not have to calculate it by ourselves. They have been given to us by the calculator. And these are the values. This is the value for M, and this is the value for B. They are given to us once this equation is input into the calculator. Again, you'll notice that the equation does not have an equal sign. Instead, it has this symbol, the approximation symbol. Next, all that we need to do is substitute these numbers for M and B to give us Y equals 3.317x plus 77.196, which simply means that the test score of a student can be predicted by multiplying 3.317 times the number of hours of study plus 77.196. So how can we use this equation to predict the test score of a student who studies for 4.5 hours? Well, all that we need to do is substitute 4.5 for x and then solving it. And in doing that, we get 92%, which means a student who studies for 4.5 hours will obtain 92% on their exam. How cool is that? We see that as the time spent on studying, hours studied increases from left to right, so does the exam score of a student. So there is a relationship, or if you want, an association, or another word for it is correlation, between the time spent studying and exam scores. This type of association or correlation is called a positive correlation. So how shall we describe the association, or if you want, the correlation between the number of hours spent studying and the exam score? Are we going to describe it as strong, very strong? Is the association weak, or is it very weak? How do we make that determination? We use what is called correlation coefficient to make that determination. Correlation coefficient measures the strength of the correlation between the independent variable, the study time in this example, and the dependent variable, the exam score in this example. For a positive correlation like what we have here, the coefficient R is a number that ranges from 0 to 1. The closer the value of R is to 1, the stronger the correlation. Now, how do we obtain this number, the coefficient of correlation? Well, fortunately again, we do not have to calculate it by ourselves. It is given to us by the calculator right here at the bottom here. And for this data, the coefficient of correlation, R, is equal to 0.71. So based on this, how are we going to describe the association? Is it strong? Is it very strong? Is it weak? Well, 0.71 is kind of like 71%, right? Are you going to describe 71% as strong or weak or very strong? I would say 0.71 is strong. So we can say that the association between the amount of time a student spends studying and their exam score is strong. It's a strong correlation. Again, be reminded that the value of R for a positive correlation is a number between 0 and 1. This scatter plot is an example of a strong positive correlation. We see how almost all the dots are completely lined up. It's a strong positive correlation. This scatter plot is an example of a negative correlation. We see that as the x values increase, the y values decrease. It is a strong negative correlation because if we drew a line of best fit through this point, we'll see that the data points are not too distant or will not be too distant from the line of best fit. This scatter plot is an example of a weak positive correlation. We see that the data are all scattered around, but overall in a positive direction. The plot shows a weak negative correlation. We see that the data are scattered around, but overall in a negative direction. This scatter plot shows no correlation because there is no general positive nor negative trend. Now is the time for us to do a little bit of practice. So for each scatter plot below, choose the type of correlation and estimate the correlation coefficient. So take your time and try to do this problem. Well, the answer is A. It is a strong negative correlation. We see that the dots are almost completely lined up on a potential line of best fit. So A is the right answer. Now take a guess on what you think the correlation will be. Well, the right answer is D. There is a general positive trend, as we can see in the graph. However, the data are all scattered around. So D is the right answer. There is a weak positive correlation. B is the right answer to this practice assignment. We see that the data are all in a general negative trend and scattered around. So therefore, that will be a weak negative correlation. And again, know that correlation does not necessarily mean causation.